tutorial, we saw a simple introduction about structural design and what is structural design also. Also, we saw the assumptions in the structural design at the beginning. In this tutorial, we are going to study about the area of a part of slab which transfers the load to the nearest beam and the load transferred to the beam. This is the plan which I have finalized for to the one of my friends for the construction in a non-coastal area. This plot size is 40 feet by 60 feet approximately. The plan I have prepared it, and for this plan we are going to arrive this structural design. This is the portico, this hall entrance only. This is hall, this is kitchen, this is one bedroom, this entrance is here, another entrance is the another bedroom, this is an attached bathroom, in another bedroom is here, this is for attached bathroom. This bedroom, hall and etc. There is a common bathroom here. This is an utility area for fixing wash basin etc. This is a outer exit. This is staircase area. By this, it is a separate staircase area because the uh, owner likes to construct two more houses in the first floor for letting to rent. So the plan in the first floor will be entirely different, and according to that, there is to fit in that this plan, the structural design has to be made. This is first floor plan. The staircase we are coming up this way. This is a passage. In from this passage, this is one house. This portion is one house, and this portion is another house. For entering this is a hall, one bedroom, kitchen, attached toilet. This is common toilet. This is OTS. OTS means open to terrace because there is no ventilation to this common toilet. So one OTS is required. So OTS portion has been here. This column is kept here, and the beam will run in this position. This may doubt, you may count. For this, they will in the first floor they will provide a false ceiling to this bedroom, and the ceiling will not be ugly to look at. Wherever the beam becomes exposed, the false ceiling will be provided. Similarly, the second house is coming here. This is a two-bedroom house. This is one bedroom, two bedroom, attached toilet. This is attached toilet here. Hall. This is kitchen. So the beam is run like this. So there is no problem because of this linking this. If required, this can be linked, and a false ceiling may be provided here. We are going to construct that construct with the beams linked here, but not the beams linked here because the hall comes in the lower portion. And also the lower portion, this one is a hall in the ground floor area. So this beam is most essential because the span is high. This is 24 feet by 24 feet. One beam is essential in the middle of the hall. So we are going to provide this beam, but the web of the beam will be given in the above side of the slab, above side, because the wall only is going to come in the first floor. So the wall can be constructed above that web of the beam. That web of the beam is not a problem for utilizing in the upper floor area. Okay, so the center line is drawn. This wall is 230 mm width. So draw a line in the middle and join all the lines. That will be the center line. So center line drawing I have already made in the CAD itself. I have drawn here. This is the center line drawing. Okay. Now we are going to come to the actual design purpose. Okay. The slab, the total is a slab. This portion is a cantilever slab which is going to rest over the beams extending from the main building like this. So we shall think about this later. Now we shall think about the simply supported slabs. The slab load goes to the beam. It is assumed that the slab portion near to the beam gives the load to the beam. For this, you draw a 45-degree line here as well here. Link this with a line. Here also the same. Likewise, in all the places, it means this part of the slab gives the load to this beam. this part of slab transfers the load to this beam. This portion gives the load to this beam. This triangular portion load transfers to this beam as well this. In the next panel, there will also give some load from that panel. So this beam receives the load from two parts of the slab, whereas this beam receives load only from one part of the slab. So automatically the load received by the edge beam will be less and the load received by the intermediate beams will be higher. Likewise everything. Here also you draw a 45-degree inclined line. This load comes here, this load. So this entire portion's load will go to this beam. This beam means there are two beams and we shall calculate how much load will come to this beam and how much load will come to this beam. We shall do in the next class. For this, it is the assumption we are making. This is the prescribed method of arriving the loads to each beam. Okay, this we have done this. Okay, how to calculate the load of the slab transferring to the beam? This is calculated. We have already calculated in our previous section that load per square meter of the slab. We have already calculated. So that load into this area of this part will be the total load of that slab. Okay, now we should find out the area of this part. This base dimension is 3.2 meter. So what is this area? Area equal to 1 by 2 half BH equal to 1 by 2 into base 3.2 meter. H means this one is H. This H is 1 by part 50% of this area. It means 3 by 2. 3 by 2 by 2 equal to 1.6. 1.6 meter. How much this value? 3.2 into 1.6 by 2 is the area of this part, 2.56 m square. As well, this part and this part will be equal. How much will be this part? By this area, the trapezoidal area, this trapezoidal area equal symmetrical. So this must also be 5.6 m square. So 1, 2, 3, 4. 4 areas we have calculated. Similarly, we can calculate all the triangular or trapezoidal areas, and then we are going to calculate the load of that slab, that part of slab transferring the load to that nearest beam. We shall continue in the next stage. As said above, I have worked out the area of each part of the slabs and I have written that square meters in the required panels. Now, this slab from this portion to this portion are supported on four sides. So there are four beams which supports the slabs in all the sides. But this is a cantilever area. The beams from this side extends to that cantilever area and the beam goes to a cantilever. The slab between this beam is rested over that beam as a simply supported slab. So theoretically, we are assuming that this simply supported slab transfers the load to this beam and this beam. And there is no beam in this side, this is the cantilever end. So the free end, there is no beam. So we are, for the assumption purpose, we are calculating that the 50% area transfers the load to this beam and this 50% area transfers the load to that area, like this. So similarly in all the panels actually, and also this is a staircase area. The staircase slab is like this, the steps are like this. So the staircase slab, base slab, is called as base slab. This base slab is rested over this beam and this beam only. This slab does not give any load to this beam. This slab does not give any load to this beam also. So the total area is divided into two, and the 50% part is giving the load to this beam and the balance gives the load to this beam. Likewise, we are going to calculate that area. For example, if we calculate this area, this is 5.1 meter length. 5.1 meter length. The width is 1.03, meaning 5.1 by 2 is the length of span, width of span is 1.03. This is the area. Now put the area here, 2.63. This is also 2.63. Similarly, fill up all that. This staircase area, if we can consider, this length is 3.3 meter, width is 2.06 meter, length is by 2. So 3.35 by 2 is the length into width is 2.06. Area is 3.45 and this is 3.45. In addition to this cantilever area. What is the cantilever area? This length is 2.06. This 50% part 2.06 by 2 into cantilever length is 1.03. 1.06 meter, 1.06 meter. Similarly, other places. 3.27 by 2 into 1.03, 1.68. This is 1.68. This is same length, so this must be also 1.68, 1.68.